All right, let's get started. Question number one. Now, there are many questions in periodic table that are linked to other chapters. So, whichever belongs to this chapter, yeah, sure, we're going to go with that. But whichever one belongs to other chapter, what I'm going to do is that I'm going to help you with that part or the question or sub question, whatever that is. All right. To begin with, part A is definitely belongs to this chapter. So, go ahead.
Mm, Um,
Any idea? Come on, it's just a memorization question. Either you know it or you don't. Okay, let's do one thing.
it's bromine.
Great, it's bromine. The only non-metallic liquid at room temperature, and there is only one, is bromine. The only metallic liquid at room temperature is, what's the only metal that is liquid at room temperature?
Uh, uh,
The periodic table starts, chapter starts with a periodic table. Right after a periodic table, we have a metal and a non-metal difference table. These exceptions that I'm asking from you right now belong to those tables, that table actually. So yeah, this is the first and foremost thing we ask the student to memorize. Since there are only two liquids in the entire periodic table, at room temperature and pressure, there is only one liquid that is a metal. There is only one liquid that is a non-metal. Non-metal is bromine, and the metal is mercury. Keep that in mind. These kind of questions are usually asked in the question as one of the examples you can see in front of yourself. So yeah, part A, bromine. Let's move on. Part B. I can hardly hear you. Please be a little loud
um,
and a little bit clear. Now that's better. See, go ahead.
it is carbon.
What? Carbon? Have you said
Um,
carbon?
yeah.
Okay, beta, read the very first line of the question. It says we need to pick from period 4. So yeah, the group 4 is the correct way to guess it, but it has to be an element from period 4. So in period 4, which element lies in group 4 and period 4? Okay, since you're having a tough time with this, you need to open up the periodic table in front of yourself. Do you have the periodic table in front of you?
Yes, sir, I opened it.
Okay. As soon as you open it, there is group 4 written on top with this sign, obviously, and there is carbon. Go below that group, but try to match an element that belongs to period 4 over here. So, which element lies in group 4 and period 4? Which one is this? That is low carbon. You're taking too much time. Come on, come on, come on. Hurry up, hurry up. Ariba can do it.
Um,
Below carbon, what do you see? Right below carbon.
silicon.
But silicon belongs to group 3. Oh, sorry, period 3. So carbon belongs to period 2, silicon belongs to period 3. Which element belongs to period 4 in the same group? So there is silicon.
Germanium.
Germanium. That's your answer. Okay, keep that in mind that we have to choose elements from period 4, the same horizontal row as germanium. Bromine also belongs to the same line. A few steps right after germanium, you had bromine. So try to pick out of
Right,
this
sir.
row. Okay, that was the very first description of the question. Question गौर से पढ़ा था? नहीं ना?
No.
Okay, okay. Let's continue. A metal that violently reacts with cold water, and that has to be from period 4.
Potassium.
Potassium, good. All right, moving on. It has a complete outer energy level.
Krypton.
Krypton, good. Moving on. It has oxidation states of 2 and 3 only.
How is it 2 and 3? Uh,
Different oxidation states are carried out by transition elements. So it is one of the transition elements. Yesterday, no, actually, day before yesterday, when we were talking about naming, we talked about a specific substance that can form a plus 2 ion and can form a Cl2 substance, or can form a plus 3 ion or form a Cl3
iron.
salt. Iron. Good. Now you're getting the hang of it. Okay, moving on. Next type, it can form an ion of the type X. Is it minus? It's a little difficult to see on the photocopied
Uh,
portion. Let's consider it
uh,
as minus, X minus, all
yes.
right?
Right.
Okay, X minus.
Um, it is
Which of these groups have the
sir.
element G?
Selenium.
What?
Selenium.
Selenium lies right below which element? I mean, which group is this?
This is good. Okay, no, no, no. It's bromine.
It's bromine. So that was a repetition. Usually the questions like this have a repetition. Sometimes children tend to go with different answers for these, but they may repeat. So keep in mind there were no rules up top, which means we need to keep an open mind about the answers. And when you need to keep an open mind about the answers, answers can come as double, means something can be repeated at once, more than once, something can not be repeated at all. So there are many options. When it's an open-ended question, it can be anything. Last part, G. One of its oxide is the catalyst in contact process. Since you haven't studied it, so vanadium, V. And actually, the catalyst oxide that we use is V2O5, vanadium 5 oxide. Okay? This actually belongs to chapter number 7 and chapter number 9.
Okay, sir.
I hope you're writing it side by side. on your hard
Yes,
copy?
sir.
Good, good. Let's move on. All right. Question number 2.
Choose an element which fits each of the following descriptions. It is a yellow solid which burns to form an acidic oxide.
Now, acidic oxides are a part of chapter number 5. It should be yellow in color and it burns to form an acidic oxide. Now, since we're done with chapter number 1, it was also part of chapter number 1. Non-metals form acidic oxides. We studied that back in acid rain. Non-metals we used or talked about were these. Now, this formed an acidic oxide. This formed an acidic oxide. This actually formed two acidic oxides. Now, out of these, one of them exists as a yellow solid. Which one does?
Nitrogen dioxide.
No. Out of these, I've circled out of these, the circled one, not the oxide. Come on. These are all gases. One of them,
Nitrogen.
nitrogen exists as nitrogen gas. Come on. Have you seen it as a solid ever in your
Uh,
life?
no.
No, of course not.
Mm,
Come on.
Sulfur.
Sulfur, great. Nitrogen exists as a colorless gas, nitrogen. The carbon exists usually in the form of coal or diamond, whatever the forms are. They are usually black in color. Sulfur is the only solid that is yellow over here. So yeah, it is sulfur. Now, since there are no options, you may write the name or you may write S, whichever one is correct. Okay. Now, moving on. Number 2.
Yes. This element is a black solid which, when heated, forms a purple vapor, and this will be iodine.
Perfect. Number 3. Number 3 is a little tricky.
Most of its soluble salts are blue. um,
Remember, if it's forming colorful salt, right? It's the transition element. Now, unfortunately, this is something that we haven't studied so far. It's not a part of chapter 1, 2, or 3. A couple of hints are given in chapter 4, but mostly it's a part of chapter 5, 7, and 9. Chapter 5, 7, 8, and 9, actually. So this one is copper. Okay.
yes, sir.
Okay, the next one.
As which is used to treat acidic spells. Sir, what is MO?
Okay. M means the metal is combining with oxygen, and MO is the type of formula. M2O is also a type of formula. MO2 is also a type of formula. This may depict that it is CO2 or it is NO2 or it is SO2. It's actually a depiction, all right? I'm just telling you. Now, this clearly tells us that this is a basic oxide. So M mostly stands for a metal which combines with oxygen in which there is one metal ion and one oxygen ion, all right? Again, unfortunately, it is from chapter number 5 and chapter number 1. This is the oxide. So the name of the element, calcium.
Right, sir.
All right. It was a little bit discussed in chapter 1, but mostly it's a part of chapter 5. Okay. MO is a depiction. Don't forget that. You can see the one metal ion, one oxygen ion. Okay.
Right, sir.
Next up.
It is an unreactive gas used to fill balloons. It is helium.
Helium. Good. This one is helium He. Try to copy the writing style that I am doing over here. I'm writing these for a purpose, not just for the recorded video, for you to understand that sometimes there are some specific writing ways which are usually like loved by the examiners, which actually clear you yourself when you're writing your answers as well as the examiner. All right,
Okay, sir.
good. Now I'm going to erase it and we're going to move forward. Okay, good. Question number 3. For each of
For
the
each of
following unfamiliar elements, predict one physical and one chemical property. ये हुआ ना फंसाने वाला question. Okay, a quick revision. Physical properties belong to their appearance. It's something that can be described physically, but not as a chemical reaction. It can be color, it can be state of matter, it can be about melting points, boiling points, it can be about density, it can be about hardness, it can be about electrical or thermal conductivity, it can be about malleability or ductility, it can be about sonority, right? All of or shine. These are all physical properties. When it comes to chemical property, a chemical property is something that can always be represented by a chemical reaction. So it can be a reaction with air or oxygen, it can be a reaction with water, it can be a reaction with an acid or an alkali, it can be a loss of electron or a gain of electron, but they usually do in terms of oxidation or reduction. So it can be anything that can be expressed in a chemical reaction. All right. Now, since I've revised,
right.
it should be easier for you to move with this. Now, take these elements from their groups or from as a whole the part of the periodic table, whichever one we have studied. For example, we have studied cesium as a part of group 1, vanadium as a part of transition elements as a whole, and fluorine as a part of group 7, halogens. So you can, of course, write their physical chemical properties. This is specifically a chapter 3 question.
The physical property of something, we can do that it has a low melting and boiling point. Or we
This
can
is
write a
about
particular that it is
your
calcium.
cesium.
Yeah.
Okay, physical property, it has a low melting and boiling point. Very good. Chemical property,
Um. Um. We can do that. It reacts with water to form hydrogen and an alkaline solution
very good.
because
Reaction with
types
water
with one metals too.
to form alkaline solution or strong alkali based solution and hydrogen. Good, perfect. Moving on. Part B, vanadium, physical property.
It is a transition metal, so we can write that these are much less reactive than the metals.
Is that a physical property?
Uh, no.
Reacts with
Um,
is something that is taken as a chemical property. But again, you never told the chemical property, you actually compared it with the group 1, which is not the answer to this question. Please not make comparisons in this question. So let's start with physical react
they are
property.
hard and strong.
Hard
They're
and
hard and
strong. Perfect. Hard and strong. Moving on. Chemical property.
um, they have more than one valency. Can that be a chemical property?
Perfect. More than one oxidation state. Please use stick to the words that are given in the book. The book says more than one oxidation state and not the word valencies. So more than one oxidation state. Perfect. Chlorine, F, physical property.
Um, they all form diatomic molecules. I mean, no, no,
Forming a diatomic molecule is means they are going to share electrons and form a covalent bond, which is a chemical bond. And chemical bond is a result of a chemical property. So yeah, that is a very good chemical property, but that does not act as a physical property. So I'm writing that as a chemical property. You're still are supposed to tell me the physical property.
um, they, it is, um, it is poisonous. Can
Poisonous.
I?
Great. What about the pale yellow color? Pale yellow gas, right? The colors always
Yes.
act as a very good property. So you can tell anything colors if they are out of the ordinary. So since fluorine is the only non-metal with a pale yellow gaseous appearance, it is something out of the ordinary. You can always tell it, but poisonous is correct too. Good. When you're done writing on your hard copy, please let me know so that I can clear it up and we can move forward.
Done, sir.
Great. Let's clear up. Let's see what do we have as question number 4. Great question. Whoever is the author or the compiler is picking up some very old questions, but good ones to go for. Okay, so remember the table below includes the information about some of the elements from period 2. So we are only discussing period 2. All right, let's keep going on. Okay, part A.
Why does neon exist as a single atom, but fluorine exists as molecules? It is because neon is already stable and
How is it stable? Good. That can get you 1 mark, but not the second mark.
because neon is a noble gas and it belongs to group 8 and all of the elements have um, full electron.
Great. That's the second reason. Because neon's already stable. Why? Because it has the complete, its outermost shell completely filled, or odd 8 electrons are there in its outermost shell. That's a great answer. So please make sure you write both the parts. Stable, complete, octet, slash, valence shell, electrons, So neon as single atoms. Oh, they also asking about fluorine. If we don't compare it with fluorine, we're not going to get the second mark. But fluorine needs one electron, so diatomic molecules. All right. Make sure you write the complete answer. I missed this part out. That's why I'm going a little out of line. So
Okay.
mention name neon on the start of the question. Neon is stable, complete octet, whereas electron shell, fluorine 7 electrons, exists diatomic molecule. I didn't read the last part of the question. I was a little bit vigilant. Make sure you pay attention to it. Don't be me.
Mhm. And then so
Done? Okay, part B. What determines the order of elements in the period?
the atomic number is the proton number.
The atomic number or the proton number? Great. So, proton number. Good. Let's move on to part C. I'm going to clear it all up. Okay. Part C. When liquid nitrogen boils, the following change occurs. Nitrogen is going from liquid state to the gaseous state. The boiling point of nitrogen is low, even though the bond between the atoms in a nitrogen molecule is very strong. Suggest an explanation. They've asked you a difficult question. It's been a while since they have been asking this question. So in the very old papers, they did ask this question, and during the times of 2013, 2017, they stopped asking the question. You don't see it much. After 2017, they've started touching this question again. So yeah, and since I've discussed it in the chapter, so I guess you can answer it. If not, I'll help you with it. Go ahead, give it a try.
Um, like, it was written for the according to lectures, boiling point of nitrogen is very low, meaning that bond between atoms.
Any idea? Okay,
Um,
let's not put too much time to it. Let me tell you, if something is in liquid form, so like this, and we convert it into gaseous form, which means we are boiling them, the boiling point of this kind of substance, and if it's a covalent molecule, remember that in case of ionic compounds, we do break the ionic bond to melt it or to boil it. We break them apart. When it comes to metallic substances, we do break the metallic bonds when we need to melt or boil them. But when it's about a covalent molecule, we do not break the covalent bonds. All right, they stay intact. What do we overcome? We overcome the weak intermolecular forces among their molecules. So that's what you need to mention over here. Low boiling point because it's easier to overcome weak attractive intermolecular forces between small molecules, small N2 molecules through heat, right? That's a great answer. This doesn't consist of every single part you need to explain to the examiner about your understanding and how he should perceive that you understand the question. Okay? This is low boiling point in the very start of it.
Done, sir.
Good. So next up, I'm going to clear it up. Let's move a little bit forward. Draw a diagram showing the arrangement of the outer shell valence electrons in a molecule of nitrogen. So you are about to show a molecule of nitrogen N2, which looks like something like this. Go ahead. You can tell me orally what's going to happen, or you can tell me, or you can draw it on a piece of paper and send it to me, whatever you like.
So we have to draw the arrangement of the outer shell, right?
Sorry?
We have to draw the arrangement of the outer shell only, right?
Right, that is correct. Since it's mentioned in the question, you can't do any other way.
We're just going to sir, should I send it to you?
I can hardly hear you.
I'm saying, should I send it?
Yeah, sure. Don't wait. I've already said about it.
Okay.
Okay, in fact, I'm going to draw it over here. So one with dots and the other one with crosses. And there is lone pair on other side, each side of it. So yeah, like this and like this. This should be your diagram, part of the diagram. Then this. 2 marks for all three steps. If you had done it in the exact same way, that's fine. If you have added this and this to the final diagram, then that's also fine.
Yes, sir, I did that, sir.
Good. That's good enough. Can we move forward?
Yes, sir.
Okay, question number 5. An element is M, has the electron distribution this. Now, moving on with these parts. Since I've stated that in a very good detail, also the starting part of it belongs to chapter 2 in, but the end of chapter number 2 is very much linked to chapter number 3, and that actually acts as a prerequisite. So I think you can easily do it. Go ahead, give part A try.
Which group in the periodic table is element and likely to be in group 3?
Perfect. And how do you know?
Because the last number means
Is
the
3.
alternation. Yeah.
Good. Group 3. Great. And that's how you write it. Do not write it in numbers. Writing group 3 is wrong. Okay, moving on.
Um, predict whether element N is a void or a conductor of electricity. Give a reason for your answer. It is a where metal because it's in group 3.
Did you say poor?
Yes, it is a poor metal.
No, group 3 are good metals. You don't need to write them as poor metals. Aluminum is not a poor metal. Apart from boron, all the elements of the group 3 are good metals. So yeah, good conductor of electricity because it's metal. Metal and good conductor,
Right. So,
right?
sir, looking
Since
on page 56, um,
they
the the
mention them
green
as
color.
green ones and the green ones are weak ones, does not mean they are poor conductors. They are a little bit weak conductors, but the word poor conductors is used for insulators as well. Do not mention that poor conductors are as weak conductors. No, that's not it. The word poor actually uh, talks about insulators, almost insulators, and weak metals are not insulators. Okay,
Yes, sir.
good. Next up,
Um, I don't know the answer for that.
there is such a big example in front of you. Come on. Binding compounds contain 2 atoms per molecule. All right. For example, HCl, identify an element which can form a binary compound with element M. Now, since it is present in group 3, it is going to have a 3 plus charge. So if we combine it with something that can have, my bad, that can have a 3 minus charge, they can both form mx, something like that. Let's suppose this is x. So what can have a 3 minus charge? I've already taught you that.
Nitrogen.
Nitrogen. Great. So nitrogen is a good answer. So D. Now M has 3 plus, sulfate has 2 minus. Find out the formula of this compound. It shouldn't be difficult. We practice it a lot.
M2 M2 bracket SO4 and 3.
Bracket SO4 and Trini, bracket SO4 thrice. How many times do I say it's the same thing? Come on.
Yeah, yeah,
That's
I
good.
recall.
M2SO4 thrice. When you say thrice, the next person automatically understand there should be a bracket before. So we don't have to say the bracket out loud. We simply call it M2SO4 thrice. Okay. So I'm going to clear up the whole thing. Let's move further. Let's see what do we have in E. Okay. Choose an element from the periodic table to match each description. You may either give either the name or the symbol. So moving on. Okay. You may give either the name or the symbol. So it's better to fill them all up either with symbols or with names. Symmetry is always important. Though you won't have your marks cut if you don't go otherwise, but it's better if you go with symmetry. So, one, it's the most reactive metal.
Francium.
So, you said francium, right?
Yes.
Good. Moving on. Only non-metal which is liquid at room temperature and pressure. RTP stands for room temperature and pressure.
It is bromine.
Bromine, good. An isotope of element is used as a fuel in nuclear reactors. It previously was a part of the course. This is not a course part of the course anymore. Okay. Although this is hydrogen, an isotope of this was deuterium. Deuterium is used as a fuel in, oh no, sorry, that's not it. Fuel. I didn't see it. So uranium, it still is a part of the course. Okay. Next up, the group 7 element that is solid at room temperature and pressure.
Iodine.
Good. Moving on, this element is in group 5 and period 4. Now that's a good extrapolation technique. Go ahead.
Group 5. Arsenic.
Arsenic, good, yes. And this unreactive gas is used to fill lamps.
Argon.
Argon, AR, good, right? I hope you have already written these.
Yes, sir.
Good, I'm going to clear it up. Let's see what we have next. Part D, period 5, rubidium to xenon. Part 1, identify element C. This should be easy. We have practiced it.
Identify element. This is
Your voice is breaking off.
antimony.
Antimony. And how did you find your answer?
I added all of the values and then I knew that it would be in group 5. So
Okay.
that's how I.
Since there are five, this means it's in period five. And says this is five, this is group five, group five in period five, and that is antimony, SB. Moving on. Number two.
Which element in the list does not form any compounds? Uh, element B.
Good.
No,
Element B. Why? Because it has 8 electrons in its outermost shell. Okay, moving on.
which element in the list forms a chloride of the type XCl2? Um, element F.
No, element F is not the answer. It's going to, element F is going to form XCl, not XCl2. This is XCl2. So element F is not going to form it. It would form FCl, which is not the point over here. Okay, so
Which element in this forms a chloride of the type HCl2? Um, um, element A.
element A, good. That's the correct answer. So it's element A, because that's in present in group 2 and it's going to definitely going to form ACl2. Okay, so moving on.
Which two elements would react to form a compound of the type XY4? It would be element E and um, um, element C.
E and C, no, that's not correct. E is correct, but C is not correct.
Um, can you repeat the elements? Like if already been done, can you repeat it?
Yeah, there is only one, already one repeated. So there are 4 atoms of Y with 1 atom of X, which the formula tells you easily. So yeah,
It would be 1 second. I'll just do the calculation.
I didn't get it. What did you just say?
I'll just do the calculation. I know the element name, but I don't know the element E and element A.
E and A. No, that's not right. A is not correct. E is correct.
I don't know.
E and F. Come on. EF4. This needs only one electron to fill its outermost shell. This has four electrons to spare, so it would be something like this.
Oh,
Come on, that was easy. So EF4. So EF4, two elements E and F is enough. Okay. So
yes, sir.
let's clear it all up. Let's see what we have next. Which element in the list would react with cold water to form an alkaline solution and hydrogen?
Um,
Come on, this is easy. Remember, alkaline solutions are formed by either group 1 or group 2.
yes. Element A.
Element A, that's correct. We'll put A over here because it belongs to group 2. Okay, moving on. Question number 6. Again, a great question.
Oh my God.
You've already done a question from potassium to krypton, so it shouldn't be difficult because this one is a repetition.
Yes. For each of the following, select an element from period 4, potassium to krypton, which matches the description. A metal that reacts rapidly with cold water to form a compound of the type liquid oxide and hydrogen. Um, Potassium.
Potassium will form MOH, not MOH twice. In order to form MOH twice, it has to be an element from group 2. If we have
Calcium.
if we have 2 coming over, this must be it. It must be 2 plus. And 2 plus, yeah, calcium. Now you're right. Okay, moving on. Oxidation state 0.
It would be krypton.
Good. KR. Next.
It has a macromolecular oxide which has similar physical properties to those of diamonds. Uh,
Come on. We have only studied three macromolecules. It's one out of those three macromolecules. This should be easy. There were only three macromolecules: diamond, graphite, and silica. Which one do you think it is?
um, Silica.
Very good. Si. Moving on. This is one of the metals alloyed with iron in stainless steel. Yes, the question from yesterday's alloys portion from the alloy table.
Um, nic- Nickel.
Nickel. You may write nickel, you may write chromium. Any one of these is fine. Moving on. A type X negative type ion can be made. Don't worry about the word reduced.
Um, negative type. Bromine.
Good. PR. Next up, form a covalent hydride and the formula is H2 dash X. Now, since water can form H2O, this means it is below the group of oxygen, below oxygen in the same group.
Selenium.
Selenium. Good. Moving on. Soluble salts are blue and the oxide is black since we have done it before. So I'm going to tell you this one. This is copper. Next up,
It is a liquid at room temperature. It would be bromine.
right, Br. So that completes the question. Let's move on. Question number 7. Part A1. It's for period 3. Again,
Um, the periodic table the current complex numbers includes the negative types. Number of valence electrons would be the same as the group number.
The valential electrons. This is pretty easy. Come on. The group number and the valence shell electron numbers are same. So,
Yeah, that's very good.
right? Easy enough. Now the valency is something that
Yes.
we wrote as the start of part 3.5 chemical formulae.
It would be +1 for like
Yes, move
sodium,
on.
and then +2,
Right, move on.
and then +3,
Right,
+4,
right.
-3, -2, -1.
Perfect. And all of this just got you 2 marks. Okay, moving on. What is the relationship between group number and the number of valence electrons?
It is that the group number is as same as the number of outermost electrons or number of valence electrons.
Yes,
It is
perfect.
equal.
Same or equal. Good. Explain the relationship between number of valence electrons and valency per element Na2Al. Now, here comes the formula that I wrote on that day. I hope you remember for group 1 to group 3, group number was equal to valency. Or valency is equal to plus into group number. It's the same thing. Remember?
Yeah.
Because these are same. Okay. So moving on, I'm going to clear this up. From P to Cl, 5 to 7. Remember, I told you that valency is equal to group number minus 8. And then your answers are going to be -3, -2, -1. Because 5 minus 8 is equal to -3. 6 minus 8 is equal to -2. 7 minus 8 is equal to -1. Or you may
Let's say
write, yeah, go ahead.
it is a 4 mark. So if you write that, will we get 4 marks, right, for both of them?
Just a second. I did never scroll down for the marks. Oh, 4 marks. That means we need to explain the relationship. So after writing this, you're going to use these 2 lines for this one and these 2 lines for this one for the explanation. Loses the number of electrons to attain nearest noble gas arrangement or configuration, whichever one you want to write. All right. And for the next stuff, gains and the rest of the stuff is same. Gains the number of electrons to attain the nearest noble gas configuration. Make sense? And that's exactly something
Yes.
written in the book.
Dancing.
Good. Let's clear this all up. Let's move forward. Okay, cross a period, the elements change from metallic to non-metallic. Oh, so this definitely is not from chapter number 3. Describe how the type of oxide changes across the period. So it moves from metals form basic oxide and non-metals form acidic oxide. Usually, we're going to start with usually, or you may write it at the end. Okay. First half of the sentence is going to get you 1 mark. Second half of the sentence is going to get you another. This belongs to chapter 5, topic 5.3. Next up. In fact, you can answer the next question, so I'm not going to answer it. Try for the next part first.
Yes, sir. Describe how the type of bonding in the chlorides formed by these elements changes across this period. It is from ionic to covalent.
Right. But you need to describe. So you need to explain that metal form ionic chlorides and non-metals form covalent chlorides. That's how you're going to get 2 marks.
Sir, could you please repeat what we just
Metals form ionic chlorides and non-metals form covalent chlorides.
right, sir? Thank you.
Okay, good. So we're done with this too. All right, question number 8. Now, since you can see you're seeing similar kind of questions, so they're going to get easier since you're doing the same questions in a practice. So every time a repetition comes over, it would be easier for you to solve. So go ahead. Question number 8, part A. Now, for the open-ended question, you'll find that they are explaining the rules. For example, in this question, the last line says, each element may be selected once, more than once, or not at all. So they're not going to leave it as an open-ended question to be exact.
Right, sir. Part A, these two elements are in the same group. It will be element A and element E.
A and E, good. Moving on.
This element forms a fluoride with the formula of the type XF2. Uh, element B.
It's F3. No, it's not B.
Element E.
It's not E either. F has a 3 beneath it. Okay, try and understand the trick over here. I'm gonna give you one hint. So if it's a metal, sometimes the metal groups from group number 3 can end up having +3 charge. Now, since they're going to combine with F, they're going to form AlF3. So this happens if a metal and a non-metal is acting in ionic bonding. This one is specifically covalent bonding because you don't have anything ending with a 3. That's not one of your options. So which other non-metal is going to do the same? Think about that again. Okay. And I'll be back in a minute. All right, so I'm back. What do you think it was?
I'm still thinking.
Okay, for any element that is present in period group number 5 needs 3 more electrons bonded with it, and you might have seen nitrogen to make a bond like this with hydrogen, so it's going to do the same with fluorine. So if it's any group 5 element such as nitrogen, if we don't write it like this, it would be F, F, and F ending up as NF3. Makes sense? So which element is going to do the same thing from this whole list? Since I've already told you the explanation, but not the answer exactly. Nitrogen belongs to which group?
Group 5, so it would be element D.
Element D. That's it. Good. So try to pick the hints. He may not exactly be talking about ionic bonding all the time. He may talk to you about covalent bonding too. So think in both ways. Now, part C. This should be easy.
This element reacts violently with cold water.
So,
Um, it would be element C.
C, great. Next up, has a macromolecular structure similar to that of diamond.
It would be element B.
Good. Let's move on. Let's see what do we have next. The only oxidation state of this element is 0.
It would be F, element F.
Good. Part F, this element is bromine. They have been very specific in this case.
Element E.
Right. Next, G, good conductor of electricity.
Element C.
Yes, great. So we're done with the question. Moving on, question number 9. Now you're going to see this rule again and again. Can be chosen once, more than once, or not at all. A pretty common pattern of questions from IGCSE?
Yes. Choose the best from the following list to answer the question. It is a product of respiration. Uh, mm,
General knowledge, not exactly chapter 3. Yes, that
Carbon
was
dioxide.
right. More of a chapter 1 question. Part B.
Um,
Unfortunately, that's a part of chapter number 10, so I'm going to hint it out. This, the part B is this. Let's move on to part C.
Krypton for part C.
Good. Part D.
Sir, what is the answer for part B?
I already circled it out.
Okay, okay. It is the main component of air. Nitrogen.
Good. Part E. Come on, this is easy.
It would be hydrogen.
Seriously? Okay, let's me rephrase it. It's the most reactive nonmetal on the planet. Not just a very reactive nonmetal, it's the most reactive nonmetal on the planet.
Carbon monoxide.
It's a nonmetal. It's not a compound. It's just an element. And there are a total of 4 elements in there: hydrogen, krypton, nitrogen, fluorine. It's not a compound.
It would be fluorine.
Fluorine. Yeah, now you got the hint of it. Good. F.
I didn't see fluorine.
Vigilance has to be a part of examination. Okay. So, moving on. Okay, this specifically is not a question from this chapter. To be honest, this is a part of chapter number 9. So I'm going to fill it out for you. And you go ahead to solve G part. Last one is this question. And G is actually from chapter number 1.
It would be hydrogen.
Good. F is sulfur dioxide, G is hydrogen. Let's complete it and move on to the next question, question number 10, which is again a copy of a similar question we did a few questions back.
Yes.
So now you see, they have been kind of repeating the pattern of their questions.
For the first one, the physical property would be that it is poisonous.
Okay,
In the chemical property, you can write that it forms diatomic molecules because it is a halogen.
okay, good. B part. And they have been very specific in this case over here. They are asking about a non-metal carbon, but the specific form it is present in is graphite. So think wisely before you come up with a physical or a chemical property. So, physical property.
Um, it is it is soft. It is soft.
Not as soft exactly.
The
Remember,
melting
the
point is
table that we studied yesterday was a comparison between diamond and graphite. That's why it used the term. Graphite exactly isn't soft. Come on, think. It's a non-metal.
the melting point in no.
No. Again, the lower melting and boiling point for in comparison to diamond, it still has a very high melting and boiling point. That's why they have mentioned it like graphite.
It is
Because
less dense.
it is what?
Less dense.
No, as comparison to all the non-metals, it is pretty dense, but it is less dense than diamond. Don't compare it with diamond. Come up with the general physical property.
It conducts electricity.
It can conduct electricity. Great. Chemical property. That's the only non-metal which can conduct electricity, remember. Okay, so chemical property. And by the way, you could have written it's slippery. You could have written it's slippery for the physical property. You're yet to tell me the chemical property. Now, children get stuck over here as this is extremely easy. Can it react with air or oxygen in the air or water or an acid? Any one of these? Oh, come on, I've given you such a big hint. Okay, I'm gonna elaborate my hint. Can it do that?
Yes.
Then react. It reacts with oxygen to form carbon dioxide, or it burns in oxygen to form carbon dioxide. And that's a chemical reaction.
Okay.
मैं आसान जबान में बताऊँ बच्चों को पता कैसे समझाया करता हूँ अगर केमिकल प्रॉपर्टी सोच रहे हो और कुछ समझ में ना आए तो एक दफा सोचें क्या क्या हम उसे ऑक्सीजन में साड़ सकते हैं अगर आप उसे साड़ सकते हैं ना तो लिख इट बर्न्स इन ऑक्सीजन टू फॉर्म दिस दैट्स वन ऑफ द इजीएस्ट वे टू कम अप विद द केमिकल प्रॉपर्टी ठीक है द गुड पार्ट
Yeah.
अबाउट कार्बन इन एनी फॉर्म इज दैट हम उसे हमेशा साड़ सकते हैं so burns in oxygen to form carbon dioxide pretty easy right and an easier way to
Yeah.
remember it too a typical Pakistani way to remember it. Okay, moving on.
Yeah.
Manganese, a transition element.
It is a good conductor of electricity, or
Good.
we
A
can
chemical
say that it
property.
hardens.
Good. All of these physical properties are correct. Moving on to the chemical property.
Uh, it has more than one valency.
Sorry?
It has more than one valency.
No, I corrected you last time. You're not supposed to write valency. What are you supposed to write then? It has more than one what? Oxidation state. Let's choose the word that is
Yeah.
written in the book and take the words right out of the book. It has more than one oxidation states. Perfect. And let me tell you, manganese has very oxidation states, very many. So it's not just one, it's not just two, it's not just three, even more than three. So we're gonna discuss it later in chapter number 5 and 7 and 9, different chapters. Okay, moving on. Question number 11. Again, a similar kind of question.
The table below shows the elements in the third period of the periodic table, the number of electrons in their outer energy level, their oxidation state in their common compounds, and their melting points. Describe and explain the variation in oxidation state across the period. The oxidation state increases as we move from left to right.
Yes, but at a certain point it stops increasing. So what would you write over there?
Um,
Because it increases. Take a look. It is increasing all the way from here to here. Then it does not increase. So yes, you can write it increases from group 1 to group 4. What happens after?
After group 4, it starts decreasing.
It decreases with a dip. It does not start decreasing. And then what happens to after group 5?
After group 5, yeah,
From here to here, what happens then? So
it lowers
increases.
and then it decreases.
No, it's actually increasing. Minus 3 is a smaller number, minus 2 is a bigger number, minus 1 is even a bigger
Yeah,
number than minus 2, and 0 is the bigger number of all
yeah.
four of these. So let me tell you, increases, then a dip, then increases again. That's
Mm.
how you need to write it and mention it as per group. So it increases from group 1 to group 4, then there is a big dip in between group 4 and 5, and from group 5 to group 0, it increases again because of the difference in metallic direct. Make sure you write it. So consume these three lines exactly as I said. So let's write the variation. Actually, no, not the variation word. That's not right. Oxidation state increases from +1 to +4 from group 1 to 4 and dips down to -3 in group 5 and then increases again, not again from -3 to 0 in group 5 to 0 / 8 due to metallic vector. And that actually is a great answer. For 3 marks, actually, you were supposed to discuss the increase between 1 to 4, dip between 4 to 5, and increase again from 5 to 0. But along with that, just to make sure that we get all 3 marks, we have added a fourth point in there, which is metallic character. You may also write outer number of electrons, but since outer number of electrons take more space than metallic character, that's why I stick to metallic character. I hope you get the point, right? And if you have too big of font,
Yes, sir.
you will not be able to write all of this in the given space. And remember, if you're taking too much and oxidation state, I this was a mistake. It's oxidation state and O should be capital. Okay, so then you can simply take out the word group out of all of these. You can simply mention G. Don't write the whole word group. Okay.
Yes,
The
sir.
first three elements, Na, and Al, are metals. Describe the structure of a typical metal. Can I erase it all?
Yes, sir. I'm done
Good.
writing.
So this is a 3 mark question. Again, for 3 marks, how are you gonna mention the structure of a typical metal in 3 to 4 points?
uh, what do we? What do they mean by this structure? Like, do we need
Okay,
to describe?
metal structure can be explained with the help of metallic bonding. Metallic bonding was explained with the help of a single diagram. That diagram has specific 3 to 4 points which can explain any metal on the planet. So go ahead, explain that specific metallic bonding diagram in 3 to 4 important points. Go ahead. If you need to take help from the book, open up the book, take help from it, and then mention your answer and try to make a whole 3 line answer. I can wait for your answer and then tell me the whole 3 line. Make sure to have 3 to important 4 points to explain this whole thing. And for that time being, while you are at it, I am going to get a glass of water. Okay.
Okay, sir.
So are you done forming with your answer or are you still at it?
I think I'm done.
Okay, go ahead. Say it out loud.
It is that metal consists of giant structures of atoms which are arranged in a regular pattern, and so the electrons of the outer shell are delocalized, and so they have the they're free to move, and then that is sharing of the delocalized electrons by strong metallic bonding.
Sharing? How come? No, it's not sharing. Don't use the word sharing. Plus, you're gonna write metal atoms in the start of this description. Okay, replace the word atoms with metal positive ions or cations, any one of these. Don't use the word sharing. Instead, you can write that these delocalized electrons surround the whole structure. Okay, there is one very important point missing out of this, because of which you're not going to get 3 out of 3 marks. You're probably going to get 2 out of 3 marks. So you've already explained that metal has positive ions, which are regularly arranged in the form of layers. You've already explained that the outer shell electrons are delocalized and surround the whole structure. There is one very important thing missing for the formation of metallic bonds, that is the force of attraction. So how are you going to mention it? They have strong electrostatic force of attraction between the delocalized electrons and the metal ions. So how to mention all of this in 3 lines in a good way to make sure that you get all the marks. So here's how you're going to do it. Metal cations are tightly packed, regularly arranged in layers surrounded by delocalized electrons and with a with strong electrostatic forces of attraction forms metallic bonds in them. Okay. So metal cations are tightly packed, regularly arranged in layers surrounded by delocalized electrons and with strong electrostatic forces of attraction form metallic bonds in them. This is the structure of a typical metal. So you mentioned cations in a regular arrangement layers. One, delocalized electrons surrounding them. Two, strong electrostatic forces of attraction. Three, metallic bonds in between them. Four. 4 points for 3 marks. That's actually more of a perfect answer. Get the point?
Yes, sir.
When you're done writing, let me know. Okay, so what's the point of saying this yes, sir, with a smile? What's the smile about?
Yes, sir. Could you please repeat yourself?
I mean, you just said yes, sir, with a smile. So what was the smile about? It means I keep finding mistakes in your answers. Is that about it?
No, sir.
Then what is it about? This must be about something. And I'm going to assume it's actually good or funny. So what was that about? Come on, let's be a little bit frank with one another and honest with one another too.
No, sir. It's not about that.
It was what? Am I coming up with too long of answers?
No,
Am I coming up with difficult to remember answers?
no.
Okay, good, good. I'm happy if you're saying no to it because sometimes the students are very honest and they tell me, yes, sir, your answers are a little bit difficult to remember. So, yeah, I understand. The answers with the perfect kind of wording are difficult to remember. But what I try to ask my students is that you can rearrange these sentences and you can come up with your own words, but you cannot forget the keywords out of it. So the keywords are metal cations are regularly arranged in layers. Secondly, surrounded by delocalized electrons. Thirdly, strong electrostatic forces of attraction. Fourthly, if you can write it in the same 3 lines, then at the fourth point, they form metallic bonds. If you cannot write it, that's fine. Try to stick with the first three as compulsory for 3 marks. Okay. So I asked them, you need to mention the keywords and you can use the other words in your own way. And then something laughable comes around. They tell me that, sir, your keywords cover the most part of it. So if I can change one preposition in or out, and what's the point of changing them? So it's like memorizing your whole answers for better marks. So yeah, sometimes it comes like that. But if you can get a good grasp of it, you can start writing your own answers in your own words using these important terms as a part of your answer. Because if you're going to look at the marking scheme, you'll see that they only write the important keywords around so that you would know what was correct for your answers. So I'm going to move forward. I'm going to assume that you are done writing, right?
Yes, sir.
Good. So let's clear it up. Since you have already written by any MG and ALR good conductors of electricity, okay, this is related to part B. What's the answer to this one? Why are metals good conductor of electricity?
Because they're metals.
No, that's not the answer. Come on. It's related to metallic bonding. Why are they able to conduct electricity? Because they're metals is not the answer.
Because they're surrounded by delocalized electrons, and so
No, you're right about the delocalized electrons part, but not about the surrounded part, because the delocalized electrons are free to move. Don't forget the key phrase free to move, because the delocalized electrons in them are free to move. That's actually a perfect answer to part C.
I think
Okay, part D.
which element exists as diatomic molecules? It is fluorine.
Chlorine, great. Next is part E.
Silicon has a similar structure to diamond. Explain why silicon has the highest metal quarry. Uh, because it has the giant covalent structure.
Good, but that can only get you 1 mark. What about the second mark?
Um,
With a huge network of strong covalent bond extended throughout the network. All right. Giant macromolecular structure. Instead of writing covalent, it's better to write macromolecular. Has giant macromolecular structure with strong covalent bonds extended throughout the network. A perfect answer for 2 marks.
Sir, could you please dictate it?
Has giant macromolecular structure having strong covalent bonds extended throughout the structure.
Extended?
Throughout the structure.
Okay, sir.
Having giant macromolecular structure with strong covalent bonds extended throughout the structure or throughout the network. You may write the word network or structure, that's fine. Okay, mentioning giant macromolecular structure, strong covalent bonds extended throughout the structure are the 3 points that are going to get you 2 marks for these 2 lines. I assume you're done writing, so I'm gonna move forward to question number 12, page number 66. So which page up to were we supposed to complete this portion?
Um, I'll check.
It was something like 74 or 76?
Yes, it is 75.
75. So we are done with what? How many
We are
pages
done
are we done with? 65. So you have
5.
10 more pages to go. 10 or 11 more
Yeah.
pages to go, which is going to be mostly similar questions. So I am pretty sure that you'll be able to do it. If you're not able to do it, anything, let me know. Send me a screenshot. I'll help you with it. Okay, question number 12, part A.
Radium is a group 1 element. It has similar physical and chemical properties to other elements in group 1. Predict how many electrons there are in outer shell of the radium atom. It is 1.
Good. Part B.
Predict
Don't
1
write the
physical
whole
property.
sentence as an answer. Simply writing one or one is good enough. Okay. One of these will work fine. Part B.
Yes, yes. Predict one physical property of rubidium which is the same as that of a transition element such as iron.
Great.
Um, mm,
So rubidium is definitely not as strong as iron. It's definitely not as hard as iron. It's definitely not having a high melting or a boiling point or a high density as iron. These are not the properties which are same in a transition element and in an alkali metal. So what is same in terms of physical properties for transition elements and alkali metals? Think, come on, be quick. That is easy. Okay, there is a big table of differences between metals and non-metals, and on that table we have every single property of a metal. So if I have counted a few properties that are not the same, there are many properties
good,
given
good,
over there. Huh? Go ahead.
good conductor of electricity.
Good conductor of electricity. That's great. Transition elements and alkali metals are almost the same good conductors of electricity. Okay, moving on, part C. I have already answered this question, so this shouldn't be difficult.
It is that rubidium is hard.
Huh? No, of course
No,
not.
no, 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 no. Yeah, it's like yeah. I, I told it wrong. Um,
Yeah, it came out opposite. So iron is hard, rubidium is soft, first line. What about the second line? Make sure you write it in a similar way. Iron is
iron,
hard, but rubidium is soft in the first line. What about the second line?
iron is higher melting point.
Good. Iron has a higher melting and boiling point than rubidium. Make sure you write it in the similar way. It's a comparison question. When a comparison question is asked, you actually compare it properly. तो आप या तो दोनों एलिमेंट्स लिख के एक को हायर देन या लोअर देन कह सकते हैं, मेल्टिंग बॉइलिंग पॉइंट्स में ऐसा कर सकते हैं. अगर प्रॉपर्टी डिफरेंट नेम या डिफरेंट एडजेक्टिव से बताई जाती है तो मेक श्योर कि आप दोनों के एडजेक्टिव्स लिखें. बाज बच्चे लिखा रहते हैं आयरन इज हार्ड. दैट इज नॉट करेक्ट एनी मोर. 2010 में इसकी मार्किंग स्कीम में वो करेक्ट होता होगा, अब नहीं होता. Iron is harder than rubidium. Or write iron is hard but rubidium is soft. Because we use the word soft for alkali metals. हम क्यों word soft करते हैं इस्तेमाल alkali metals के लिए? Alkali metals हमारे पास छुरी या कैंची से कट जाते हैं. You can cut them with a knife. But you cannot do the same with the rest of the metals on the periodic table. बहुत सारे ऐसे हैं, सिर्फ चंद एक ही हैं अल्कली अल्कलाइन अर्थ मेटल्स में से जो सॉफ्ट की कैटेगरी में फॉल करते हैं और बड़े आराम से छुरी से कट जाते हैं, बाकी नहीं कटते. ठीक है. So rubidium is soft, iron is hard. पहली लाइन. दूसरी लाइन, iron has a higher melting and boiling point than rubidium. THAN वाला then. ठीक है. और इसके ऑपोजिट भी आप लिख सकते हैं. रिवर्स आर्ग्यूमेंट इज ऑल्सो फाइन. रुबिडियम हैज अ लोअर मेल्टिंग एंड बॉइलिंग पॉइंट एज कंपेयर टू आयरन. ये आप सेकेंड लाइन में लिख सकते हैं. राइट. आई होप यू डन राइटिंग. सो वी गोना मूव अहेड. डी. When rubidium is added to cold water, a reaction occurs. डी पार्ट वन करें.
Yes.
अब मैंने आपको एक
When
अच्छी
you
सी
go,
वीडियो दिखाई हुई है. ठीक है. जबरदस्त म्यूजिक वाली जिसमें हम उठा उठा के अल्कली मेटल्स को पानी में फेंकते थे. And we saw what happened to those. So if we're gonna throw rubidium in a cold water, what two observations, visual observations you can make in front of yourself?
rubidium metal reacts very rapidly with water, and so a colorless solution of rubidium hydroxide and the hydrogen gas is formed.
Come
This
on,
pattern,
observation means what you can see in front of your eyes. Do you see in front of your eyes hydrogen gas to be coming out? You only can see the bubbles of a gas. So bubbles of gas,
rubidium is entered in the water, so it's
so violent
um,
reaction, bubbling, rubidium catching fire, rubidium forming a ball and moving on the top of, floating on top of the layer of water. These are the observations that we made, right? So on
can
top of
you please
these, the two observations that you can write and can be easily correct is that vigorous bubbling and rubidium catching fire or rubidium exploding. Okay. Remember, whenever they talk about observations, they do not want you to talk about the background chemistry. They're only asking you what you would see in front of yourself. हाइड्रोक्साइड का सोल्यूशन बनता है वो आपको नजर नहीं आ रहा होता कि हाइड्रोजन ऑक्सीजन के एटम मिल मिल के हाइड्रोक्साइड का सोल्यूशन दैट इज जस्ट एनिमेशन दैट यू कैन नॉट एक्चुअली सी फ्रॉम अ विजुअल ऑब्जर्वेशन नेकेड ऑब्जर्वेशन में आपको क्या नाम नजर आ रहा होता सामने बबल्स बन जाते हैं धमाकेदार एक रिएक्शन हो जाता है रुबिडियम को आग लग जाती है that is what you can see in front of yourself. So rubidium agent catches fire, or it's an explosive reaction, or there is some vigorous bubbling with it. These can be the part of observations. Observation सोच समझ के लिखनी है बैकग्राउंड केमिस्ट्री नहीं लिखनी इसने उससे रिएक्ट कर लिया ये बना लिया नहीं दिस इज बैकग्राउंड केमिस्ट्री वी कांट सी इट विद आवर आईज ठीक है फॉर एग्जाम्पल जब कोल को बर्न करते हैं हम और कोयला ऑक्सीजन के साथ रिएक्ट करके कार्बन डाइऑक्साइड बना रहा होता है तो फॉर ऑब्जर्वेशन हम ये नहीं लिख सकते coal reacts with oxygen and forms carbon dioxide. No, that's not the observation. That's the background chemistry. What do we see in front of ourselves? The coal catches fire, glows red hot, produces a dense white or colorless gas. That is what we can see in front of ourselves. देखिए ना बारबेक्यूज या बॉनफायर्स में कोयला जो होता है वो ग्लो करना शुरू हो जाता है रेड से कलर का या समटाइम्स फायर कैच कर लेता है और उससे हमारे पास व्हाइट सा स्मोक जो ना उसके ऊपर से निकल रहा होता है दैट इज व्हाट वी सी इन फ्रंट ऑफ आवरसेल्फ हमें कार्बन और ऑक्सीजन के एटम आपस में टकराते हुए डबल बॉन्ड बनाते हुए नजर नहीं आ रहे होते दैट इज बैकग्राउंड केमिस्ट्री आई होप यू गेट माय पॉइंट राइट
yes,
ओके सिंस इट फॉर्म्स a alkaline solution. So methyl orange has a yellow color in alkali. So yellow. Next one is yellow. Okay. For the next one, Rb, sorry, Rb plus H2O, and we're gonna write it as 2H2O. So this is RbOH, and we're gonna write 2 plus H2. That's how we write the chemical equation. Okay. Solid, liquid, aqueous, and gas.
right,
An equation having all four state symbols. We throw a solid piece of rubidium into water, which is a liquid. It forms an aqueous solution of an alkali, rubidium hydroxide, and it also gives out a gas. Okay? If even if you don't write state symbols, it will be correct. But according to this paper's marking scheme, but since the paper is too old and the marking scheme is too old, now the criteria have changed. And I always appreciate my students. So if they're writing any question in the exam, if you know and you can, please write the state symbols. Although state symbols are a part of chapter 4, but since when you're attempting the paper, you're done with the whole book, so it does not matter if you're solving a question related to chapter 1, 2, or 3, always write the state symbols. अब आते हैं part 4 के ऊपर.
right. Put the group 1 elements cesium, lithium, potassium, rubidium, and sodium in their order of reactivity with water. Put the most reactive element first. It would be cesium first,
Good.
and then rubidium,
Good.
and, and then potassium, and then sodium, and then lithium.
Great. Now you know. So this is CS, this is RB, this is K, this is Na, and finally this is Li. Moving on to part 5. When you're done writing, go ahead to part 5.
Yeah, and then so just one safety measure that should be used when rubidium is added to cold water. As we studied that the flame would come, so maybe gloves or goggles.
Okay, it's not just about the flame. Rubidium is very reactive. You have seen an explosion in that specific video. So a very small piece of rubidium should be added from a distance. So having gloves, goggles is not going to keep you safe. ठीक है? तो बहुत छोटा सा पीस होना चाहिए रुबिडियम का, क्योंकि हमें पता है वो रिएक्शन एक्सप्लोसिव होता है। जितना छोटा पीस होगा उतना बेहतर है। ठीक है, हम धमाके से ना अपनी जान लेंगे और ना साथ वाले और 4 लोगों की या उनको नुकसान पहुंचाएंगे। ठीक है, तो वेरी स्मॉल पीस ऑफ रुबिडियम शुड बी एडेड फ्रॉम अ डिस्टेंस। अपना डिस्टेंस मेंटेन करा। आपने जब देखा होगा वीडियो में, जब वो एक्सपेरिमेंट कर रहे होते हैं, डाल रहे होते हैं रुबिडियम, साइंटिस्ट दूर से खड़ा उसे ऐड कर रहा होता है, खुद करीब नहीं होता। So it's better if you use a pair of tongs to add it to. But just writing two small things that a very small piece should be used and from a distance would cover one sentence and will get you 1 mark. Okay, so let's clear it up. Rubidium phosphate formula. This is good. 3.5. Something that you have been doing flawlessly. So
Yes. I yeah. So for rubidium, it is
Rb, which is +1, PO4, which is -3, or you may
it
write
would
it as
be RB3 and um PO4.
Rb3PO4. Good. That's great. And it also finishes question number 12.